Alright folks, so today we are going to revisit something that you worked with last year in Math 2. Well, actually, it could have been last year or the year before, depending on when you took Math 2. But we're going to be looking at solving quadratic equations using the quadratic formula. But we're also going to include our imaginary and our irrational roots. But we're going to really focus on imaginary solutions. Alright, so think back to the quadratic formula. Alright, when you're solving quadratics, probably the first thing you learned to do was to solve by graphing. And we looked to see that whenever it crossed the x-axis, that was our solution. Okay. Another way that you learn to solve quadratics is by using the zero product property, where you factor your trinomial into two binomials and set each one equal to 0 and solve it that way. But in order to get solutions, you had to have specific types of quadratic trinomials to solve these. But with the quadratic formula will solve any quadratic. Our quadratic formula is x is equal to, alright, you probably learned that song, negative b plus or minus square root b squared minus 4ac all over 2a. Now, if I was in class with you, we would sing this as a class. Negative b plus or minus square root b squared minus 4ac all over 2a. Okay, so that's our formula. Notice it's got a plus and a minus. You're going to add and you're going to subtract, so you're going to end up with two roots. Okay. Alright. Now, notice right here under the radical. Well, let me give you a minute to copy that down. I'm going a little fast, aren't I? Alright. So notice here under the radical, I have b squared minus 4ac in a different color. And the reason why I have that in a different color, because this portion is known as the discriminant. Discriminant. Let's see if I can spell it today. Alright, that discriminant, the value of the discriminant is going to allow us to tell the number and type of solutions that we end up with. So let's go back and review a little bit of notes way back from Math 2. Alright, our discriminant. Alright, so as I was saying, when you first started working with solving quadratics, the first way that you learned to do this was to solve by graphing. So when our parabola intersected our x-axis twice, we knew that we had two real solutions because they're intersecting your x-axis twice. Now, remember that the x-intercept is also known as a root. It's also known as a 0. And finally, it's also known as a solution. Okay, so wherever it crosses the x-axis, that is a solution to that single equation. Now, for the discriminant, the b squared minus 4ac part, if that value is bigger than 0, which is just a fancy way of saying if your discriminant is positive, then you are going to have two real solutions. And to be more specific, if your discriminant, I'm just going to call this d, is equal to a perfect square, then you're going to have what we call two real rational unequal solutions. And I'm going to write roots. Alright, so copy that down. I'm going to talk about what that means for a second. Alright, so real means they're part of the real number system, the non-imaginary. The numbers actually exist. Okay, rational means it can be written as a fraction, a terminating, or a repeating decimal. Unequal means they're not going to be the same, so they're two different roots, two distinct roots. If your discriminant is a positive non-perfect square, a positive non-perfect square, then you're going to have two real irrational roots. And all that means is that you're going to end up with a square root in your answer. So like if we had the square root of 14. 14 is not a perfect square, so we would leave it as the square root of 14. Alright, so let's say that we were given negative 3x squared plus 14x minus 8 equals 0. And we were asked to use the discriminant to determine what type and how many solutions we're going to have. So we're going to come right here, we're going to pick out our A, our B, and our C. Now of course you always want this to be in standard form, and here it is in standard form. Ax squared plus bx plus c. With that being said, our A value is negative 3. Our B value is 14. And our C value is negative 8. Alright, so using our discriminant, b squared minus 4ac, we're going to substitute in our values. So we've got b squared minus 4 times a times c. Alright, our b value is 14. Our a value is negative 3. And our c value is negative 8. Alright, so let's see, we got 14 squared minus 4 times negative 3 times negative 8. And we see that we get 100. Alright, so since your discriminant is a positive number, that means we're going to have two real solutions. Alright, then you had a scenario where your parabola only intersected your x-axis once. Okay. Alright, when it intersected the circle, when it intersected the x-axis once, you only had one real solution. So one real solution. Because you only had one distinct root. You were only using that one number, but you were using that one number twice. Okay, and since you were using that one number twice, this is what we called a double root back then, but now we say it has a multiplicity of 2. That's just a fancy way of saying, hey, you're using that root twice. You're using that one distinct root twice. Right. Now, in order to use the discriminant to determine that we have one real solution, if your discriminant b squared minus 4ac is equal to 0, and that lets you know we're only going to have one real solution. Now, choose the way that I always tell students to remember this. What number does the word 1 start with? Well, it starts with a 0. So if you have 0 as your discriminant, you have one real solution. Alright, so let's say that we were given 4x squared minus 12x plus 9 equals 0. Alright, it's in standard form and it's set equal to 0. So let's use our discriminant to find the number of solutions we're going to have, the number and the type. Alright, so we've got b squared minus 4ac for our discriminant. Our a value is 4. Our b value is negative 12, and our c value is 9. So b squared minus 4, that 4 is part of the formula, so it's always going to be there, times ac. Alright, our b value is negative 12. Our a value is 4, and our c value is 9. Putting that in the Desmos, we get 0. So when your discriminant is 0, that lets us know you're only going to have one real solution, and that one solution is being used twice. Alright, and then finally, back in the day, when your parabola did not intersect your x-axis at all. Okay. Alright, we said that we had no real solutions. It's not intersecting the x-axis, so it has no roots, no solutions, no x-intercepts. When your discriminant, b squared minus 4ac, is less than 0, which is just a fancy way of saying negative, you're going to have no real solutions. Okay. Right. Now, back in Math 2, you said no real solutions. Well, now we're a little fancier, so here we're going to say, instead of no real solutions, we're going to say it has two imaginary solutions. And we'll talk about the imaginary numbers in just a second. Alright, so let's say that we were given the example x squared plus 6x plus 10 equals 0. Alright, so again we're going to use the discriminant to determine the number and type of solutions. So we've got to pick out our A, our B, and our C. For our A value is an understood 1 right here. For our B value, we've got our 6. And for our C value, we got 10. Alright, so here b squared is going to be 6 squared, a is going to be 1, and c is going to be 10. So basically 36 minus 40, we get a negative 4. Since our discriminant is negative, that means we have no real solutions, but we're going to have 2 imaginary solutions. Alright, so let's talk about imaginary numbers for a minute. If I came right here and asked you for the square root of negative 25, what is the square root of negative 25? Now most of you are thinking 5. So 5 times 5, that does not give us a negative 25. Then usually when I say that, you start thinking, well, negative 5. Well, if we did negative 5 times negative 5, that is a positive 25, so it does not give us a negative 25. So what number in the real number system gives us negative 25 when we multiply it times itself? Well, nothing exists. So that's where they created the imaginary numbers. We used to have a large unit on imaginary numbers, but they kind of took everything out of the curriculum, but just this little bit that we're going to look at. With your imaginary numbers, there are 2 things you need to know. All right, so you know how when I say pi, you know pi equals 3.14? Well, for the imaginary numbers, we've got a little cursive I. When you see that cursive I, which represents imaginary, it's equal to the square root of negative 1. This is the main thing you need to know right now. Whenever we have a negative under a radical, it's going to come out as an I. And I'll get a little bit more detail with that in just a minute. Also, later on in the unit, if we have I squared, well, what happens when you square a square root? The radical disappears. So when you square I, you get negative 1. This is going to come later on, but this right here is what we're going to focus on today. So if I gave you the square root of negative 36, I'm going to show you how we're going to break this down. It's very easy. All right. Negative 36 can be broken down into a negative 1 times 36. Because negative 1 times 36 is still negative 36. So I haven't changed the value. I've just written it in expanded form. Well, what do we know the square root of negative 1 is? The square root of negative 1 is I. So the negative 1 comes out as an I. What is the square root of 36? It is 6. And since we took the square root, it's both the positive and negative version. I'm going to come over here. Let's say we have the square root of negative 15. All right, again, that's a negative, so we're going to break that down into negative 1 times 15. Well, the square root of negative 1 is I, so that comes out as an I. But 15 is not a perfect square, so it stays under the radical, and we get positive and negative I onto the square root of 15. So basically, just to put it in a nutshell, whenever you have a negative under the radical, it's always going to come out as an I. And then you just focus on the number itself and see what you do with that number. Alright, so now that we got all those little background information out of the way, let's jump into some actual examples using the quadratic formula. Alright, so here we want to solve the following equations. Now, since we're trying to solve these, if they have a real answer, a real solution, You could do left side, right side and see where they intersect and get your solution that way. All right, so let's see. Let's say that we had 2x squared plus 4x minus 5 equals 0. All right, so as you're copying that down, I'm just going to rewrite the formula. Negative b plus or minus square root b squared minus 4ac all over 2a. And no, I did not sing that as a lullaby to my children when they were babies. Because if you notice, it's actually to the theme of Vera Jacques, Vera Jacques. Negative b, plus or minus square root, b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. All right, so let's pick out our a, b, and c. All right, our a value is 2, our b value is 4, and our c value is a negative 5. Now, I usually do the skeleton of the formula. So I've got negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Let's substitute in now. All right, my b value is 4, so wherever my formula has a b, I'm going to put a 4. So I got a 4 right here and a 4 right here. All right, my a value is 2. So where I have a in my formula, I'm going to put a 2. And then my c value, wherever I have a c in the equation, the formula, excuse me, I'm going to put a negative 5. Now let's simplify. That negative on the outside says take the opposite. So the opposite of positive 4 is a negative 4. I'm going to go ahead and do the bottom here. 2 times 2 is 4. So now let's do the discriminant. All right, 4 squared is 16. 4 times 2 is 8. 8 times 5 is 40. And then negative times negative gives us a positive. So what we end up with is 56. Now 56 is positive, so that tells us that we're going to have 2 real solutions. So if we were graphing it, it would hit our x-axis twice. Now, we need to see if we can simplify the 56. So what you're going to do is you're going to ask yourself, what are the factors of 56? All right, so we've got 1 times 56, 2 times 28, 3 can't go into it, but 4 can go into it, 4 and 14, 5 can't, 6 can't, 7 can, 7 and 8, and then we start repeating. You want to ask yourself, what is the largest perfect square if there is a perfect square? Well, our largest perfect square is a 4. So 56 can be broken down into 4 times 14. So we got negative 4 plus or minus the square root of 4 times 14 all over 4. All right, the square root of 14, the square root of 4 is 2. So we're going to have negative 4 plus or minus. Again, the square root of 4 is 2. 14 stays under the radical, all over 4. And then you want to ask yourself, can any of this be reduced? There's no other radical, so this 14 can't be reduced by any of these numbers here. But I see that this 4, this 2, and this 4 right here all have something in common. They all have a 2. So I can separate that simplify it by dividing by 2, the GCF. So negative 4 divided by 2 is negative 2. 2 divided by 2 is 1. So I'm going to put the 1 there just for demonstration purposes. And 4 divided by 2 is 2. So here is our answer. Alright, so to most of you that probably looks like one answer, but in reality this is actually two answers. That first answer is negative 2 plus the square root of 14 over 2, and then the second answer is negative 2 minus the square root of 14 over 2. They just combine it into one answer by doing the plus and the minus. Alright, so let's look at what this would look like in Desmos. Alright, so we know we do left side, right side. So we're going to come right here, we're going to say 2x squared plus 4x minus 5. And then right here, our right side is 0. So we're going to say, since that has no variable, we're going to say y equals 0. All right, and I'm going to make these a little thicker so that we can see them a little better. All right, so I can see that they intersect at the x-axis. And notice they're decimals. Okay. All right, so how can we use Desmos to verify our answer for something like this? All right, so I'm going to come right here and I'm going to test this answer first. All right, so this is a fraction, so I'm going to do division. So I've got negative 2 plus the square root of 14 over 2. Alright, we see that decimal right there, 0.87. So if I come right here, so keep 0.87 in mind. If I come right here, do I have that same decimal? Yes, 0.87. Right here's 0.87 as my x. So that lets you know that is a solution. Alright, if I come right here and put the minus, I'm going to change this to a minus right here. Alright, we get negative 2.87. So going back to our graph, is that negative 2.87? Yes, it is. So what we can do, if you want to use Desmos to solve your problem, because you get mixed up right here, you can look at your answer choices and put one answer choice in at a time and see if it matches the decimal value of your graph. Now, I've said it before and I'm going to say it again, and I'll probably say it 20 exponential times. Don't let the only time you practice with Desmos be when I ask you to do it in class. You need to take it upon yourself to practice with Desmos. Sitting there just staring at me work it is not going to teach you much unless you practice. Math is a physical learning class. It is a physical learning course. If you physically do not practice, you will not learn it for most of us. All right, for number 2, we've got x squared plus 4x equals negative 4. All right. Now, if you notice, this is not in standard form. Okay, so we got to bring this constant over. So this is not in standard form. We're going to bring this constant over. And you always want to try, it really doesn't matter which side you bring everything to, but I always try to keep my quadratic term positive. So I want to bring this 4 over. So if this is a negative 4 as it is, then the opposite of subtracting 4 would be adding 4. So we end up with x squared plus 4x plus 4 equals 0. All right, let's pick out our A, B, and C. Alright, our A value is an understood 1. Our B value is 4. And our C value is also 4. Alright, so negative B plus or minus square root B squared minus 4AC all over 2A. Alright, so doing our B value. Alright, so wherever there's a B, we're going to put 4. So 4 and 4 go right there. Wherever there's an A value, I'm going to put 1. So A is right here and right here. Wherever there's a C value, I'm going to put this 4. So we got a 4 right here. Let's start simplifying. Okay, the opposite of positive 4 is negative 4. I'm going to go ahead and do my denominator next. So 2 times 1 is 2. And now let's do the discriminant. 4 squared is 16. 4 times 4 is also 16. So we end up with 16 minus 16, which is 0. We know that when we have a discriminant that is 0, we're only going to have one real solution. So what we really have right here is just simply square root of 0 is 0. So if we either add or subtract 0, it's not going to change anything. What we really have right here is negative 4 divided by 2, which gives us a negative 2. So that means that one distinct root is actually being used twice. So that's a double root. It has a multiplicity of 2. So here your solution is negative 2 with a multiplicity of 2. And remember, that's just a fancy way of saying it's being used twice. So if we were to actually look at this on the graph, what we would see is at negative 2, it would intersect at negative 2. The parabola only hits the graph once, and that root is being used twice. Alright, so I'm going to use Desmos to verify. Alright, so coming right here, put the left side in. We got x squared plus 4x. And then my right side is negative 4. So y equals negative 4. Alright, this time they intersect right here. And if you notice, the x value is negative 2. If you'll finish copying that down real quick. All right. All right, so let's say that we're given x squared plus 2x plus 2 equals 0. All right, so writing down our A, B, and C. Our A value is 1. Our B value is 2. And our C value is also 2. So negative b plus or minus square root b squared minus 4ac all over 2a. I always write the skeleton of the formula first. Alright, so let's start substituting in. Alright, so our b, we've got a b value here and a b value here. Alright, for our a, we've got a 1 right here and a 1 right here. And then our c is 2. So the opposite of 2 is negative 2. 2 times 1 is 2. And now let's figure out the discriminant. 2 squared is 4. 4 times 1 is 4, times 2 is 8. So we got 4 minus 8. And that gives us a negative 4. Since our discriminant is negative, that means we're going to have 2 imaginary solutions, which means we're going to have I in the final answer. So we got negative 2 plus or minus, all right? As we said earlier, whenever we have a negative, we know that's going to come out as an I. So we got an I right here. And then the square root of 4, that happens to be a perfect square, so the square root of 4 is 2 all over 2. So we get negative 2 plus or minus 2i over 2. And as some of you are thinking, can we simplify this? Of course we can. Negative 2 divided by 2 is negative 1. 2 divided by 2 is 1, so we're left with just an I. Now remember, this is actually two answers. This is negative 1 plus I and negative 1 minus I. All right, looking at example number 4, we've got negative x squared plus 5x minus 6 equals 0. All right, take about 45 seconds and pick out your A, B, C and substitute into the formula. Again, all I want you to do is just pick up the A, B, and C and substitute into your formula. Alright, so let's see how you did. Our A value is at understood negative 1. So wherever we have an A, we're going to put negative 1. Our B value is 5. So wherever we have a B, we're going to put 5. And our C value is negative 6. So right here in place of C, we put negative 6. The opposite of 5 is negative 5. We got plus or minus. 2 times negative 1 is negative 2. And let's figure out what our discriminant is going to be. 5 squared is 25. 4 times 1 is still 4. And 4 times 6 is 24. And here we have an odd amount of negatives. So that means it's going to be a negative. If you have an even amount of negatives, remember it's positive. So 25 minus 24 is 1. Since that discriminant is positive, that means we're going to have two real solutions. Alright, so let's simplify this out. We know the square root of 1 is 1. So what we have here is negative 5 plus or minus 1 over negative 2. And we can still simplify this, so we're going to simplify it. What we have here is we have negative 5 plus 1 over the square root of negative 2. And we have negative 5 minus 1 over negative 2. Negative 5 plus 1 is negative 4 over negative 2, and that gives us a positive 2. Negative 5 minus 1 gives us a negative 6 over negative 2, and that gives us a positive 3. So our two solutions are a 2 and a 3. All right, and for our last example, I say the doozy for last. Now, as you're copying this down, you're probably noticing that it's not set equal to 0. So anytime it's not set equal to 0, you know it's automatically not in standard form. So we've got to put it in standard form from the biggest exponent to the smallest exponent. All right, now you could move the 3 over, okay? But I'm going to make this a little bit different. I'm going to do it a little bit different. I'm going to move all this over here to the right side so that this would stay so my x squared would be positive. So if it's negative on the left side, when I move it to the right side, it's going to become a positive 3x squared. For 17x, on the left side it's positive, but when I move it to the right side, it's going to become negative. So I have negative 17x. And then right here, the opposite of subtracting 2 would be adding 2. So when I add 2, I get a positive 5. And then nothing's left over here because I've moved it over there, so it's equal to 0. So now we can pick out our A, B, and C. Now we'll say if you just moved a 3 over here and got minus 5, you'll end up with the exact same answer. Okay. All right, so let's do the skeleton. Negative B plus or minus the square root of b squared minus 4 times A times C all over 2A. All right, my A value is 3. So anywhere I have an A, I'm going to put a 3. My B value is negative 17. So anywhere I have a B, I'm going to put negative 17. And my C value is 5. So anywhere I have a C, I'm going to put a 5. Now notice, my B was negative 17. I didn't let that negative count as that negative right there. That negative is part of the formula. Whatever B is what you put inside here. So the opposite of a negative 17 is a positive 17. Then we got plus or minus. All right, we'll get the discriminant in a minute. 2 times 3 is 6. All right, so let's figure out what our discriminant is going to be. All right, I'm going to come right here and I'm going to put the discriminant in the calculator. I'm not going to put the square root part, I'm just going to put the discriminant. So we got negative 17 squared minus 4 times 3 times 5. And we get 229. 229 is a prime number. Only thing that can go into it is 1. 2 can't go into it, 3, 4, 5, yada, yada, yada. Nothing can go into it. So since nothing can go into it, we can't simplify anymore. So this actually ends up being our final answer. All Now, let's test this right here. All right, I know my answer is 17. Oops, let me do a fraction first. We got 17 plus the square root of 229 over 6. And then we've got 17 minus the square root of 229 over 6. All right, so I see my decimal answers right here. And now I'm going to do the left side, right side of the original equation and see if their intersection gives me these two values right here. So the left side I had negative 3x squared plus 17x minus 2. And then on the right side I got 3, so y equals 3. Alright, so we want to see if we see these two decimals right here. So again, this is how you can test on the EOC or on my test or quizzes if they're multiple choice, which choice is actually your answer. You can verify your answer this way. Alright, so right here I see that they intersect. Alright, so I see my intersection is here and here. Are those two the same decimals that I get right here? Yes, they are. So that lets me know that my solution is correct. If I had different decimals right here, that would let me know that that answer choice is not the correct answer. Alright, so I'm going to give you a couple of problems to try. Alright, so if you'll write these down and leave yourself some room. Okay, I'm just going to write them close together, but when you write them down, you leave yourself some room. Alright, so if you'll pause this video for about 15 minutes, you can work independently or you can work as a small group, pair up, or a group of 3. But that means that if you pair up with someone or pair up with a group, you don't sit there and watch somebody else work it. You try it, you work it out, and then you compare your answers. That is how you do group work. You don't let one person do all the work and then you try to copy it, because you're not learning that way. They can't take the test for you. You've got to be able to know how to do it yourself. Alright, so pause the video for about 15 minutes. Okay, so let's see how you did. Alright, if you'll pause the video here and check your answers, and then if you didn't get something right, look at the work and see if you can determine where you made your mistake. So pause the video here for about 3 to 4 minutes and check your answers. Alright, bring it into picture the last two problems. Pause the video here and then check your answers here as well. Now that we're done, make sure that you put your name and date on the notes and submit those notes.